speaker Peter Verhas will be presenting a talk with the topic comparing GOLANG and understanding Java value types. As always, if you have any questions during the lecture, please feel welcome to ask those with the Slido app with the hashtag K100.
Thank you very much. Welcome everybody. My name is Peter Verhas and I'm a software developer, senior software developer, software architect. And in this presentation I will compare GOLANG and Java, and it will help us to understand what value types are or will be in Java. I delivered this presentation first time in April in Mainz, in Germany, and that was not a developer conference, that was a Java conference. And when I told my colleagues that I was accepted and I will talk about Go language in a Java conference, then they told me, "You are a brave man." So, the very first question related to this presentation is that if I am a Java developer, a Java programmer, why should I care about it? And I cannot tell you why you should care about it. I can tell you my story. I can tell you why I care about it. And what happened to me is that sometimes in 2015 I was reading about value types, and I understood more or less what they are. At least that time I was thinking I understood them. And then the conclusion for me was that, okay, I understand, so what? But later on, a year later, I started to learn a little bit GOLANG, to play around with it, because it was interesting. People talked about that it's so different and things like that. And then later on, I read again about Java value types. Somehow it just crossed my path. And then I realized that, now I understand it. It was like an epiphany that I understood in GOLANG how GOLANG is dealing with memory, and then how Java is dealing with memory, how different it is. And then I understood why value types are so important, what they are really about, why we need value types in addition to objects in Java. And for a Java developer, learning GOLANG can lead to two different paths. One is that he becomes a Go developer. May happen, but then the person will be happy as a Go developer, no problem. But even if that's not the aim, to become a Go developer, I am a Java developer and I want to be a Java developer, I'm happy with that. Why should I learn Go? Because Go is so different. And it has approach to certain things that I will detail in this presentation so differently that I, as a Java developer, will learn a lot and I will understand Java internal working a lot more and much better. Why it's the way like that? Why does Java do it the way like that? And before getting into the details, I have a disclaimer. I actually have three disclaimers. The first is that I am a Java developer first, and still I'm talking about Go. And but I'm a polyglot programmer. Second, since I started programming sometimes in the 1970s, so it was really a long time ago. So I know Java, so you can ask me any question about Java. Most probably I will be able to answer it. But Go is only one of the languages that I am just not afraid of. If I see a Go code, I can more or less understand what it is. If I have to write something in Go, probably I can do it, but I don't know all the details. And I have an extra disclaimer, which will just help me out of all of this, that I came from Switzerland and I have Swiss chocolate, and I will ask questions, and whenever there is a good answer for that, those of you who were here an hour ago with my previous presentations, they know I will give chocolate. So, do you speak German? Anyone? Okay, otherwise I would be in trouble. Let's start with something easy first, just to have a question. What's the answer? What is the answer to the ultimate question of life, the universe, and everything? Yes, okay. Hands, please. Who was answering it? Anyone else? Okay. 42, yes, that's the answer. Then I have another question, it's a little bit more difficult. Was ist die Antwort nach dem Leben und dem Universum und dem ganzen Rest? 42. Yeah. And I have another question. What's the difference between the two answers? Yes, the language. And the thing is that whether I say that 40 and 2, or I say in a German way 2 and 40. This is a hypothetical question, I don't want to answer for that. The thing is, if you look at it, that either of these is okay. And I cannot say that saying 42 is better than 2 and 40. It's actually history. Two different approaches. In older times, as historians say, here in Europe, in many different languages, we were saying 2 and 40, so the 2 first and the decimals after. And when trade was coming and we needed the decimal numbers, so we could calculate with the numbers, adding up the items for payments and things like that, then we started to use the decimal numbers, and then we started to use the way 40 and 2 instead of 2 and 40. But in Old English, it was 2 and 40, as like it is today in German. In Middle English, it was still 2 and 40 if you were talking about someone's age. Otherwise, it was already 42. And really, the conclusion from this is that it's not important which one we use, like driving on the road. Can I drive on the left side, or is it better if we drive on the right side of the road? In the continent, we drive on the right side. In England and in some other countries, they drive on the left side. They are just as good, but we shouldn't mix the two. In one country, we should do only one. In the other country, we should do only the other one. And this is an interesting thing, and it's important. And towards the end of the presentation, we will have to think about this again. Because this is something similar with Go and Java. But before getting into this difference, first, assuming that you all know Java, more or less, let's see what is Go. So, what is Go language? Go is the new C++, or C++ done right. That's what people say. Go is a system programming language. Yes, that's what Google say, so I should believe that because it's their language. Some people say that Go is genius. Some other people say that Go is terrible. The interesting thing is that sometimes the same people say both. And I can understand this little schizophrenia. Yes, it's genius and it's terrible sometimes. But seriously, Go is a compiled language, so it's compiled directly to exe, and there is no VM for it. It's object-oriented and functional language at the same time. We will not deal too much with the functional part of it in this presentation because we are focusing on the objects and value types. And there is a garbage collector, but it's not a real garbage collector because so the thing is that if you talk about whether Go has a garbage collector or not, and if you are a programmer and just program them, okay, it's a garbage collector. If you are talking to someone who is very Go-minded, then you should say, yes, it's a garbage collector. If you talk to someone who knows the nits and bits and everything about the JVM garbage collector, you shouldn't say that it's a garbage collector, what is in Go, because it's not a real garbage collector. Actually, I will talk a little bit about that later. So, we will talk about a little bit about the language syntax, exception handling, garbage collection, local variables and stack, closures, just to have something functional things, GOROUTINES, and object orientation and inheritance, which again something that somebody says that there is no inheritance and real object orientation in Go, but in my opinion, there is. So after all, if you have a look at what there is or there is not, it's a matter of terminology, how you call it. And terminology usually doesn't really matter. It's just a name. I will only slightly touch these areas because these are not really important from our point of view in this presentation. And I will talk a little bit more about object orientation and inheritance because these are the things that will teach us the most. So, first of all, the syntax is very easy. It's C like Java or C#, C++, Perl. But there are some things. For example, if we have an if statement, then Go says that those parentheses around the if are not important. It's just noise, so it doesn't need it. And if I have, for example, an example, if 42 equals z, then we print this, otherwise we print that. This is a sample Go program that you can see on the screen. You can play around with Go with playgo.org, or I don't know, I will have the URL at the end of the presentation. So it's, if we have the curly braces, we don't need the parentheses around the logical expression. And generally Go says that if we can skip some character, then it's just noise, let's skip it. Likewise, if he says that we declare variables, we're saying that they are variables, so var, there is a keyword, then the name of the variable, and then we specify the type. This is not Go syntax. What syntax is it? What language is it? Sorry? Did you say Pascal? Pascal, yes. It's Pascal. And Go says that it's okay, except there is a character that we don't need. Which one?
Colon.
Colon, yes. We don't need that colon. Okay. But and also we can have an initializer expression. And if we have an expression, an initializer expression, then we may not need what? Type. Chocolate. Who else was there? Okay. So in that case, we just have an var x expression. And we had an extra character that we were throwing away. Instead of these three characters var, we can use that extra character that we saved up before, and we can say that we have x let equal expression, and this declares a variable, initializes it with a value, and the type of the expression is inherited by the variable, or it's given to the variable. So it also declares the type. Very simple and very common in Go language. So again, if we look at the very same example, then we can see that z is declared to be a string and has the value answer. Okay, so if a variable is declared but not used, So it gets a value, but it's never read. It's an error in Go language. Because it says that, why do you need that? I mean, probably you don't need that, then it's an error, it's noise. If you import a package, but you don't use it, then it's an error. So it's nothing like, yeah, it's okay, but you have a syntax analyzer or style analyzer, like whatever, check style or things like that. No, Go says that something that is rubbish. And again, he says that semicolon is usually at the end of the lines is just noise, so we don't need them. It actually does that with the preprocessor and inserts them, but we don't care about that. And they also say that writing everywhere, public, private, that's a nightmare. Anything, a function or variable, which starts with a capital letter is public, lowercase letter is private. It's freaking me out, but it is. So, functions. There are functions, no methods, only functions in Go. And these functions or methods can also have a receiver. Do you know what receiver is? That's the this. And do you know that with Java 8, Java also introduced this terminology, that receiver? Have you ever heard about that? In Java 8, if you have a method, you can specify the type of the class, space, this as an argument. And it's the same as if it was not specified as a formal argument. You know why Java does that? Because this is the only way you can annotate it. It's just an interesting extra thing. Okay, let's go back to Go. So, usually we just separate the parts of everything with spaces and parentheses when they are really needed. So, here is an example. My function has an argument which is an int, and then what it does, it just prints out the answer is and the value. So if I run it on play GOLANG org and this URL, you get immediately this simple program, and then it will print out 42 on the screen. Another example, there is a structure which is something like class in Java or value type. We will look at that. And that is the receiver of the my function, and it doesn't have an argument. So if I create such a structure, like on line 10, and I invoke the my function on this very similar way as I would do it in Java, then it will just print out 42. Again, I have a function that has an argument which is an int, and it returns two values, an int and an error. So functions can return multiple values. And then I return the number itself, the int I, and nil, which is the null in GOLANG. And then something interesting. My function doesn't have any argument. It has a receiver, which is a structure named MyStruct, and it returns a function, because functions are first-class citizens in Go, and you can return a function. We will have an example of that later. So, exception handling. There are no exception in GOLANG, no exception handling. Methods just return multiple values, like in Python, and usually they return a value and an error status. And the caller should handle that. And this is how it should be done in Go. But there is a panic. Actually, the Go developers who develop the Go language say that panic should not be used like Java exceptions, because when there is a panic, then you can actually catch that. But you shouldn't use it for exceptional things. You should check that on the error code. You should use it what we use in Java, errors, not exceptions. There is a distinction between exceptions and errors. Yes? And there is a differ statement, and it's very much works like finally in Java. So if I open a file and there is no error while I open the file, then I say I will close it before I return from this function, from this main function. So I call f close, but I defer it sometimes later. And then there can be some code here on this line, between line 13 and 14. Garbage collection. For the programmer who programs in Go, there is an automated garbage collector, and you do not need to care about that. For the hardcore JVM guys, there is no compacting, and there is a good reason there is no compacting. So after it collects all the garbage, the memory may just be like Swiss cheese with a lot of free holes and occupied places. There is no compacting. The reason for that is that Go doesn't use references, it uses pointers. And if you move something and the pointer still points to the place, then you have a problem. So the data structures cannot be moved in the memory in GOLANG. And that's the reason why there is no compacting. Local variables on the stack. Big question. If there is somebody who is programming for ages, what happens if I return to a pointer to a local variable in C language? Yes, undefined behavior, and most probably I will use up some memory that is not allocated, and then I get some core dump. Yes? What happens if I return a pointer to a local variable in Go? No. The compiler will recognize that this local variable is escaping the scope of the function. So this variable has to be stored on the heap and not on the stack. Do you know anything similar to that, just the other way around? There is an object inside the method. Escape analysis says that it will never escape from the scope of the method, therefore it can be stored on the stack and not on the heap. Java 8. You don't know? Java 8 does that. If an object is allocated in a method, not too big, it can allocate it on the stack after a proper escape analysis. So, when we do this, then we will get just a local variable that is returned, and then we can use it. And allocation is extremely simple. Closures. Functions can be defined inside other functions, and the surrounding part of the function is a closure and becomes part of the function. So if we return a function as a result, then Go is functional, and it is. For example, I have this counter factory which has a argument, int argument j, and I is declared to be an int because it inherits the type from the right side expression j, and then it returns a function which doesn't have an argument but returns I and increments I. So the variable I becomes part of the function and the environment, and calling this function that we return 3 times will print out 13, 14 and 15. GOROUTINES. GOROUTINES are lightweight threads, fibers, so they are very effective and very fast, and they don't need... What's this noise? Comes from the other presentation? Yeah. It's a little bit annoying. And actually, I was thinking they are threads, and I tried to ruin the machine, just starting a few tens of thousands of them, and I was very much surprised that I could start 10,000 GOROUTINES, and they were just working fine, and they were not overloading the machine. And there is a built-in type called channel, which is a fixed-sized first-in, first-out queue, and the different GOROUTINES can communicate with each other through channels. So instead of shared memory and locks and things like that, which are still available in Go, they say that you should have asynchronous GOROUTINES and you should pass variables, values between these through channels. And then we go for the main thing, objects in Go, how objects are treated in Go. The major thing that you should remember, if nothing else, you should remember about this talk if and when you start learning about Go, is that there is an interface in Go. But if you are a Java developer, then I recommend that if you have electronically the document that you read Go from, then you do a global search and replace interface with just abracadabra or something, because it's nothing like a Java interface. It's something totally different. And if somebody tells me that before that, it would have saved me 2 days. It's something totally different. In Java, you define an interface, which very much looks like an interface in Java, because it just lists the methods that are in this interface. But the classes, or there are no classes actually, so you don't implement these interfaces. There is no implements keyword. There is a structure type in Go language, and if there is a structure and there are functions that use this structure as a receiver type, and each and every method which is defined in an interface are implemented, then this structure implicitly implements that interface, but it's not declared that way. And it's very interesting that structures cannot extend other structures. So there is no inheritance, but they may contain other structures. Okay, what's the deal? I mean, in Java you can also. But when you contain another structure and there is a method which has that other structure as a receiver type, I can also invoke that function on the big structure, and it automatically understands that I want to invoke it on this embedded function, embedded structure. Therefore, it's like I extend that structure. Syntactically, it looks like if I extended it. And very easily this way, I can have multiple inheritance this way, because I can embed multiple different structures into my big structure. And also, if I have the same structure embedded many times, then the compiler will realize that in that case, I have to specify on which element I want to invoke that function. So this way, there is no extension, no inheritance, but there is containment. And with containment, you can actually implement very much the same things as with inheritance. And functions that operate on a certain type. And if I want to compare then these differences, then I can say that in Go, we have interfaces. In Java, we have interfaces. The structures do not implement declaratively the interfaces, but they do. In Java, we declare what implements what, and we have extending, inheritance. In Go language, the structures contain, and functions work on a structure type. In Java, the methods are inside the class. And in Java, variables are either class type or interface type, but they are not much different. And we will see why it's not much different. In Go language, they are much different, because in Go language, we can have a variable which is structure type, and we can have a variable which is interface type. And this is the major difference between Go and Java. Because in Go language, objects are headless. In Java, when you have an object, it has an object header, which is 8 or 16 byte, and it's in front of the object data. So when I have an int value as an integer object, then I have 32 bits of an int value, and that's 4 bytes, and I have 16 extra bytes as an object header. In Go, we don't have that, because it has a struct and no headers. And the consequences of that is that if I have an array in a Java, then I actually have an array of references, unless we have array of primitive types, which are actually value types. Primitive types are already value types. And in Go, if I have an array of structs, then I have a continuous array of memory that one after the other contains the data. I can also have an interface array in Go, but that's a different story. Then I am doing it deliberately. So, in Go, when objects are headless and a variable that is a struct type, then it holds the value itself. Or if it's a pointer, then it points to a certain struct, to a memory location. But to know what's in there, not the data, the type, how big the memory it is, where the fields start, how it's packed together, I don't need an object header, because the compiler knows the type of the variable. Also, if it's a pointer to struct, I know the structure of the variable. If I have a variable that is of interface type, then it has a pointer to the structure, and we do not know yet how big that structure is, because there are different structs that implement this interface, that can have different size and can have different fields in different orders. But the variable itself also has a reference to the structure description. So the header information which is stored in the header in Java before the object is stored in the variable. And when the variable has a value, gets assigned a value, then either it's a static type, so it gets the value from a struct variable or an expression which is a structure, and then the type is known, or it gets the value from a different interface variable, and then the value and the type information is also copied. And that's a very, very important thing, that interface variables are 2 slots in this sense in Go. And it's very much different. And just let's have a very weird example that will burn into your brain. Yeah, especially if you are Java developers. I have a structure, contains nothing. I have a method that has this structure as a receiver. And there is an interface which defines this function. So this structure inherently implements this interface. And then I have an interface variable, and I specify the type. I cannot inherit from the right side the type. So it's a my interface. It's an interface variable, but it's actually nil. So it's a null pointer kind of. And still, what will happen if I invoke my function? Sorry?
It will work.
It will work, yes. It will work. Oh, it's damaged. I'll give you another one. It will work. Because in Java, you cannot invoke a method or anything on a null pointer. Because it points to nowhere, there is no header. But if I invoke on an interface variable in Go a method, then I know the type. And the null pointer itself is just a value, and like an argument to the function. So it works. And now something completely different. Java value types. What are Java value types? So actually Project Valhalla was started in 2014. And we already have value types. Byte, short, int, long, float, double, character, and boolean are all value types. And Project Valhalla aims that user-definable value types should be there in Java. And value types are not objects. So they will not hold only the value. They will hold only the value and no header for that. And if we look at it and compare what value types are, then we see that they are very much like GOLANG structures. GOLANG essentially has only value types and not objects. And the interface and the object header, where do I store it? That's the question. Why do we need value types? For example, there are candidates even in the GDK for value types. If I have a date, I mean, not like that, I'm married for 30 years, but a Java util date, then it's essentially 32 bits, like an int. And I have 16 bytes header for it. Why do I need that? All the date things can be done as value types. Then all objects have a synchronization lock support, which seemed to be a good idea 20 years ago. But now it seems that probably it was an overkill. With value types we will not have header. Also, when we allocate objects, they are allocated on the heap, unless Java 8 optimizes it out. Value types are allocated on the stack. And value types, arrays, are CPU cache friendly. So when I have an array of pointer, the CPU reads a chunk of memory. I want to access this memory, the CPU reads this amount of memory. But then it goes out for the object here. Then it goes out for the object there. And the access time for something data from the cache is 10 times faster than reading it from the memory. If I have an array of value types, then everything I've read is in the cache already, so it can be much faster. And that generally, value types are things in Java, or will be things in Java, which codes like a class, but it works like an int. What are the consequences? You can compare value types with equal sign because they are not objects, there are no references, they are copies, and like 3, which is a value, and 3 equals 3, whatever. There are no instances of 3 in this sense. Value type variables cannot be null because they are not pointers or references. There will be no inheritance or just limited inheritance, because even if there is inheritance, you cannot do polymorphism because of the lack of the header, and because in Java, we don't have value types, variable types differently, which would hold the type of the variable, or we will have, I don't know. And they are passed by value. The more important thing is the consequences for the GVM. Scala has value types because it's so modern. Yes, but to implement it on the GVM, it can only have one field, one primitive field. So what? It's just encapsulating something that's already there in Java. But if we have value types in Java, then even Scala can have multiple values in it. Languages like Swift or Golang can be effectively compiled to GVM if we have value types or not. Maybe we need something more, but like GOROUTINES, I mean fibers, but that's also on the way. And many cases we can just stop joking around with off-heap memory mapped files if we need something big memory, because we can handle those with arrays of value types. So finally, do you remember how we started? Which is the better way? Where should we hold the information which is in the object header in Java? Why is it stored the way like that in one language, and why it's stored the way like that in the other language? And which is the better? And well, if we have time, or in the I can answer anything question area, we can discuss about that. And finally, the takeaway, the final conclusion is that Java programmers, for Java is good as it is right now, but it can and it will be better with value types, and Java will always be better and better. Whatever you, I mean, you can interpret it, it will always become better and better, or it's always be better than anything else. It's up to you. And if you want to play around with Go, then you can, the easiest is that you go play Golang.org, and you can very easily on the web browser play around with very simple Go programs. And generally, thank you very much for your attention.
Thank you, Peter. Would anyone from the audience like to ask a question? Okay, well, in that case, we can just move over to Slido.
Okay. Does it work vice versa? If I'm a Go developer, should I learn Java? Well, if you are a programmer, Go, PHP, anything. You know, I'm a Java advocate. What should I say? You should learn Java. Of course. Why 42? Actually, 42, that's a reference to the Hitchhiker's Guide of the Galaxy, and I think most of the audience knows it. If somebody doesn't, and then he or she should learn Hitchhiker's Guide of the Galaxy, definitely. And then after that, learn Java. Main Java pulses versus C#. That's very long. I mean, I couldn't deliver talks because I don't know C# good enough, but it's a topic that would deserve 6 or 7 or even more talks, because C# is a language of Microsoft, and Microsoft owns the whole architecture from the operating system up to very high. And because they own the operating system, C# has advantages like memory management, which they could integrate together with the operating system. If you need that advanced memory management and garbage collection in Java, then you should use some special distribution, and they exist for Red Hat operating based on Red Hat with a modified kernel, where the garbage collection is integrated into the kernel, and they have a special kernel module. But then it again runs only on that operating system version, as well as C# runs on that operating system version. And C# again is developing with versions, not keeping backward compatibility. Java was very much trying to keep backward compatibility. Because of that, Java does Java generics are not available during runtime. It's eliminated from the runtime code. So a variable, you cannot tell a variable what type it is really. I mean, the basic type, yes, but the generic type you cannot tell in runtime in Java. In C#, they can do that. And because they just did not care about backward compatibility, but in Java they had to implement it in a special way to keep backward compatibility. It's a decision, a language evolvement decision, what it was. And because of that, for example, C# has generics for primitives because it's available on runtime, and for primitives because they have different size and not just a reference to somewhere where there is an object header. When you want to execute a method which is a generic for a primitive type or a value type that was not before, then you need a new version of that method which works with different size objects, but they can do it during runtime. Java doesn't do that. So it's very much different, and I wouldn't go so much into differences with that because I say we could talk about that days, and I don't even have the knowledge about C# that much. Java versus Go in microservices, running in Kubernetes, speed, I don't think there is a big difference of the speed comparison, whether it's in microservices, in Docker, Kubernetes, or everywhere else. Honestly, today implementations, if we compare today's implementation, if you have a service, a server that you write in Go and one that you write in Java, you start up both, Java and Go will work faster because it's native code. But after a while, after it's running for a long while, Java will become faster because Java is compiling into native code during runtime. And also the JIT compiler collects runtime information, and the optimization is based not only on the source code, but also on the runtime behavior and the behavior of the inputs, the environment. And if there is an if statement that for some reason, which does not depend on the actual code, but depends on the environment, what kind of HTTP requests come to the web server, and it turns out that the if statement is 99% of the time is true, then the JIT compiler will recompile that part of the code and generate code that runs faster if the evaluation is true, and then a little bit slower if it's false, because it optimizes for true. If it changes because, for example, it's the night, and during the night the users behave differently, then at 6 o'clock, the JIT compiler doesn't know anything about the users, but will realize that now the expression is usually false, and then it will recompile again. Go cannot do that. So in the long run, Java is probably a little bit faster in many cases, but the proof of the pudding is eating it. You have to have your code, and it's very much, even I think it's more depends on how you implement these things. And if you know Go very well, you try with Java and you are not writing good Java code, then Go will be faster. If you know Java very well, then Java will be faster because you code it better.
Thank you very much. That seems to
also
be
for the questions.